be a jerk or anything, but when a crane operator doesn't know crane signals, it makes things really difficult. He didn't know the difference between boom up and hoist up, or boom down and hoist down. So that's a bummer when you see that kind of stuff. This shows you that, you know, you have to watch your back because you assume that other people know what they're doing, but they don't necessarily.
This video is brought to you by Sporlan. Quality, integrity, and tradition.
Starting today off just a little bit earlier than usual. You know, it's approximately 6:15 in the morning, so we normally leave the shop around 7 a.m. is what we leave the shop at, but a little earlier today because we have a scheduled crane lift. We're doing a walk-in freezer equipment replacement. So we've got an existing walk-in freezer, and we got to swap out the evaporator, the condenser, and the line set. Now this is a really old system. I don't have video footage condemning it or anything. The main reason why we're changing it is because the line set, the insulation is completely compromised and it's saturated on top of the box. So it leaks condensation all over the place every time it goes into defrost. But the customer opted to change the equipment because it's, you know, 15, 20-year-old equipment, and they'd rather just get ahead of the game. They're very proactive here. So yeah, we're heading there to do it. We've got crew of guys, you know, my guys coming out there. All of us are going out there. We've got a crane scheduled at 8 a.m. We're going to get there at 7 a.m. I kind of wish, you know, I mean, it'd be great if we didn't have to do it all in one day, but, you know, it is what it is. That's how it goes. So we've got existing food in the box. We've got to keep the door shut as much as possible. We've got to, you know, do the whole swap out. So electrical, line set, condenser, evaporator, drain lines, drain line heater. We're going to get it all done. So we have a pretty good plan when we attack these jobs. The only thing, I usually try to plan everything out. Two things I realized this morning as I'm overthinking everything is I don't have a new drain line heater and I don't have a suction line P-trap. So we're going to have to figure something out with that. Luckily, we have supply houses very close to where we're at. So let's get to it.
All right, we've got our walk-in freezer equipment right here. So what we typically do, instead of having to work really hard, we'll usually pump it down on the roof, throw the gauges inside the unit, and then we recover the charge downstairs. So we're gonna pump it down, shut off the breaker, disconnect all the electrical, ruin the condenser fan blade, no. And then we just recover downstairs. So now we're gonna go find the breakers, get power turned off, start disconnecting all this stuff, and go from there. We try to make it as easy as possible.
Hello?
Yeah, what you got?
All right, shut it off right now.
Okay, hold on, let me check. All right, we have no power, turn it back on. Okay, we have power. Go ahead and turn it off. And then that's our breaker. Now that we have power turned off, we've isolated it, you know, everything's good. We're gonna disconnect power and very carefully get everything removed. We don't wanna destroy anything because we've got a lot of wiring going on here. So we're gonna take pictures, pay attention to what's what. And there's a lot of moving parts on these jobs. We have a guy on the ground watching for the crane, getting ready to unload stuff. We got two guys down in the box, disconnecting the evaporator coil. I'm up here by myself dealing with electrical stuff. We've got the condensing unit completely disconnected, so we're ready when the crane gets here. So it's all about teamwork on these jobs, communication, talking with each other. We're gonna be running a new line set, and you can see what I typically do, because they framed this one in, is I cut this piece out like I did right here and then spray foam it. And then we'll clear it up and everything. So I just cut this one out. Gonna get the line set removed. Again, I got guys working downstairs. We're just all moving, working together. My attic is totally open, so we got plenty of room to move in here. My line set is the one running over, then straight down. I know the camera's not focusing very well. With all the spray foam around it, that's it. So, shouldn't be too bad. I mean, it's gonna be difficult climbing up here and stuff, but we'll make it work. But boy, is this walk-in, I know you guys can't see it, but it's sloping really bad. We've got some issues. Huh. hoist down. Keep going. Down. Okay, stop. Centered, then I'll just boom up. Get the ball centered over your load, and he's going up. He's going up. Tell me when. We're good right there. Sorry. Oh no. I would boom up. Boom in. Good. This is hoist. No. Watch the boom. Watch the ball. Now right there. Yeah. All right, hoist down. Okay. All right. I try to do the right signals. All right, let's hoist up. So, I don't like to be a jerk or anything, but when a crane operator doesn't know crane signals, it makes things really difficult. He didn't know the difference between boom up and hoist up, or boom down and hoist down. So that's a bummer when you see that kind of stuff. This shows you that, you have to watch your back because you assume that other people know what they're doing, but they don't necessarily.
We've got the evaporator coil down. The line set and electrical is going to swap sides. So the line set's going to be on this side, electrical is going to be on this side. So we'll utilize this hole for the electrical and we'll just seal it up. This one we're going to have to drill a new hole. Now I don't like the line set hole to be directly in line with the line set coming off the coil. I prefer it to be offset right here so that way it can come down, have a P-trap, come over, and then 90 into the coil. Because when people drill them right behind the coil, there's no room for P-traps. It makes it difficult. So, okay. And then we always utilize this as our electrical so we don't have to drill an extra hole.
All right, we are on top of the box. This is my line set right there. There's a drill bit over here, right there sticking up. That's where my new line's gonna go. So I need to drill that down. I need to work on getting the electrical up. And again, I got a guy downstairs, so we're working on this together. All right, so we got two things here. We got a, this is a door switch or a twist timer for the box. So that interrupts power and shuts down the coil. So typically you'll interrupt the end, the neutral, or the common leg. And then that's gonna be my communication, my heaters and all that stuff. So again, we're just gonna push that down this existing hole, and then right where that drill bit's sticking up, we're gonna drill a hole. I got my hole saw up here, and I got a guy downstairs with a pan. He'll put it underneath there and then catch all the droppings. Go ahead and pull the bit out if you can. Okay, hold it there. I'm gonna push stuff down. Hold on. All right, that's good. Well, hang on, one more. I'm just gonna get the dust from around the hole. All right, we're good. You go ahead and move it, do what you gotta do. So what do you want me to do? Let me find them. Oh yeah, I can do it. That's one.
Okay, so we got all the old bolts out. We got the new line set hole drilled, electrical's pushed down. We got to hang the new coil and then drill the new coil bolts. So I am going to jump down because I sent a guy to the supply house, so we're short a guy for about a half hour. So jump down and help him hang the coil real quick, and then we'll drill up the bolts.
Well, I might have kind of messed up a little bit because I just realized this new coil is a lot smaller and that line set hole is rather close. Uh-oh. That mark right there is where my screw holes are going to be, so the line set's probably going to be right there. Hopefully I have enough room.
It's a mess up here. So I've got the line set, the suction line ran down here. It's coming over there. I'm going to try, if I can, to make this a one piece. I'm going to bend it, try to get it down if I can. It's going to be tight, but I'm going to try my best. All right, it kind of worked out. So we got the line set coming down. I was able to bend it in place. I did have to cut a little bit off, but it's still going down deep enough where it can catch the P-trap. We'll slide insulation up over it. Got the line set down right there, taped up, bent down. We still got to spray foam the holes. We still got to do more work, support the lines. But for now, that's it. We're gonna go work on the roof, and then I got someone downstairs working on the electrical.
All right, I'm gonna try to give you guys perspective of what I'm seeing here. That whole side of the box is sloping down. It's really hard to get the camera to show you guys perspective here. But if we pan over, the whole box, yeah, it's not gonna show you guys, but the whole box on this side is sloping down, and then on that side is sloping down. It's like everything's falling. It's crazy. Like the floor is unlevel, they got some sort of slab problem or something. It's nuts. Even when you're in the box up here and you're standing up here, down this middle is rigid and supported, but then it slopes down on both sides, and you can feel it when you're kneeling up there. It's crazy. You can kind of see it with the camera. It's scary. And then I'll show you guys inside the floor of the walk-ins. You can see they definitely have a foundation problem.
All right, and then look, this is the freezer. Look at the whole floor is cracked all the way back. I'm telling you, this whole foundation is dropping on both sides. It's freaking bonkers. All right, I'm up on the roof. I'm gonna get started on this line set. So I pulled the insulation off. I'm gonna do my best. I'm gonna see if I can bend this. I don't know if I can do it or not, or we'll have to cut it and then braze it in sections. But I'm gonna try to do it in one piece if possible. It's probably not gonna be perfect, but let's see what we can do.
So what I'm going to do is start cutting the insulation down, pull up the line set, bend it that way, and then once I bend it that way, we'll make the right angle bend, and then once we get it bent right angle, then we'll drop it back down to the walk-in because I have room to pull it up. It's not the prettiest thing, and we'll straighten it out a little bit more, but we were able to bend it one piece all the way in, and then we'll tape it all up and everything. So again, you guys, it doesn't have to be perfect, okay? If I wanted to get crazy, we could have done straight pipe, but we don't need none of that here. It'll all work out. So we're gonna get this brazed up. I'm gonna go downstairs, start helping with some drain lines. I'm gonna let Will up here braze, and then he's getting his nitrogen ready and all that stuff. Right, we're back inside the box. I'm gonna work on piping this refrigeration lines, put a P-trap. I got guys working on the drain line. We're pressing in the drain line. We got electrical coming into the coil over there, all hooked up, so that's good. So yeah, we're moving along. I bent that guy, it's coming down, going in. We did a one shot with the liquid line, that's perfect. And then suction line, we threw a trap onto it. Now, here's what we're gonna do. We're gonna braze this one, we're gonna braze this one, but we're not gonna braze this one because we're gonna slide the insulation on. Oh, I know, I'm breaking the internet because you never wanna slide insulation on a P-trap. It works just fine for what we're doing. I get it, I understand, but the coil's not gonna last that long. They rot these things out in no time, so there's no sense in trying to spend a bunch of time gluing and cutting miter fittings for insulation. It's just not practical on this kind of stuff. And we are flowing with nitrogen right now, so. All right, we got those guys brazed in. We got to inspect them with the MIRA real quick. Then we'll put a cap on here and slide the insulation on. All right, so we got the line set ran. We changed the insulation to this because I don't like the look of the UV rated insulation. We left a spot for the sensing bulb to mount, then we'll seal it up. Everything's brazed in. We're gonna start the evacuation, and then we're gonna mount the sensing bulb. We got the TXV magnet on there so we can do a pressure test. That was for brazing. And then we're gonna wrap a drain line heater around this, so we're moving along. All right, we're still finalizing some stuff. Doing a pressure test right now, and it's passing. 155 PSI, I think it started at 156, so I'll let it deviate 1 PSI or a little bit right around there, that's fine. So we're gonna do evacuation now. And we just got people working, people still doing electrical, drain line, heaters, all that stuff. So just getting ready to start this. We were doing the evacuation and came down here to mount the sensing bulb and realized that is a 404A TXV. There's nothing on the data tag labeling that this unit is 404, but up on the roof, the condensing unit is 448A and it's pre-charged. The manufacturer on this, the customer buys it direct. Right? They just have this stuff shipped to me. So we didn't check the TXV of all things. So luckily we caught it before we started it up. We hadn't even released the refrigerant. You just heard nitrogen flowing through it right now. So I got a kit in my van. I'm gonna go out there. We're gonna build a TXV and then we'll get back up here and we'll replace it. Luckily I have this kit and I keep all the TXVs in my van. So what they have in there is a straight through valve. So we're gonna use the EBQE. That's this valve right here. We have a low temp 448A system, so that is a Victor Zebra power head, and it tells you everything on here if you don't already know. And then my tonnage is gonna be, I think, a blue cartridge, 3/4 to 1.5. I think I'll have to check the tonnage, but I think it's 12,000 BTUs, 13,000 BTUs, so that's gonna be right there. So we're gonna need a blue cartridge out of here. So we'll build the valve,
and then we'll get this guy sweat in. Got a fully built 448A low temp valve right here. So I'm gonna unsweat it, get the new one sweat in. We got nitrogen flowing through. We got a solenoid magnet still on there. So let's get this. All right, I got some of the Viper wet rag heat blocking compound protecting the TXV. I'm gonna go ahead and get it sweat in. We still got nitrogen flowing through. I'm using the old TXV to kind of prop up the solenoid valve so that way my line doesn't fall out. And we're off to the races. Get this guy up and running hopefully soon. All right, TXV's installed, cleaned up. I'm just working on mounting the sensing bulb now. And get the solenoid coil back over here. We still got the magnet flowing because we're pulling the evacuation on the system right now. So, well, disaster averted, except for kind of burnt my solenoid magnet a little bit, but hey, it still works. So we've got the evacuation running. I got the sensing bulb mounted, insulated. So what I typically do is I use 7/8 by 3/4 wall insulation for the normal pipe, right? And you can see the transition right here. We're gonna tape this hole too, by the way. But then I go 1 1/8 ID by 3/4 wall for right here because it goes right over, and then I do the self-sticky stuff and then just wrap it with foam tape. So, all right, we're waiting for the evacuation, and what I'm doing is I'm filling the holes. So we have this tape that has the texture of the walk-in, made by 3M. I don't know what it is. I get it from my supply house. They have it, but it's really nice stuff. And it actually, the color matches the walk-in, you know, and over time it fades just like the walk-in. But this is cold. You can clearly see they got some sort of a leak right there too. But this is cold in here. So we got to take the MAP gas torch. You dry it off first. You heat it up with the MAP gas torch. Then you apply the tape. Then make sure it's nice and warm. And then we're going to keep going around to all the holes and doing that. And then I got someone up top and he's going to spray foam it all. All right. So we got all those holes, right? There's a little bit of foam coming out of there, but that's fine. The foam, you really don't like, when it first comes out, you can carefully kind of wipe it down, but other than that, just leave it alone and it'll dry and you can just peel it off. And then you have this hole right here. It's all taped up and it's full of foam. Those ones over there. The new coil was smaller, so all right there. All right, so we're pretty much done in here. We still need to foam this because we had to move the drain line down because this drain right here, it was too short to go through the original drain line hole because all the new coils are smaller or taller because of the AWEF compliance stuff. So we ended up drilling a hole a couple inches down. The drain line for this goes into the beer walk-in. We took care of that. We put a drain line heater on it. And that's pretty much it. So we're gonna go up, like I said, check on the vacuum and hopefully get ready to start this guy up. So this is my drain line coming through. And the secret to this is that you buy the non-expanding, like this is windows and doors, so it doesn't expand very much. It just expands a little bit. It just fills gaps, right? And then clean up the wall, heat it up, and then we'll tape it. But we taped and foamed both of them on the other side, so we'll get some tape on there now. All right, so we've got multiple people here. I've got one guy at the breaker panel, one guy on the roof. We're checking phase rotation, and we're all on a conference call, so that way he can check phase rotation. I'm down here making sure nothing blows up when we turn on power, and then we're all just working together. So it's all about the teamwork when we're doing this stuff. Another thing you got to be careful about on these is overloading of the compressors, especially on a startup, because this is a hot pull down. Now that's part of the reason why the evaporator fan motors don't start up right away. We're running about 6.5, 7 amps, somewhere in there. But the RLA on the compressor, I believe, was like 14 or something. But you always want to watch that. You want to make sure we're not overloading the compressor. We are flooding back right now, but the evaporator fan motors more than likely are not running yet. So I'm going to go downstairs, wait for the evaps to come on, and we're just going to watch it kind of run for a little bit, make sure everything's good. All right, evaporator fan motors are running. We're going to give it some time. We are frosting up coming out of the TXV a little bit. That's to be expected right now. So we're going to let the thing run, let it warm up, and then we're going to, once it gets cold in here, we're going to test the defrost heaters. So we're not done yet. All right, we flipped the guy into defrost and it tripped the breaker. Didn't even blow a fuse. It tripped the breaker right away. So we got to figure out where this problem lies. Something is going on here in this. So we shut it off at the disconnect switch. We're going to check our fuses, make sure they're not bad. And then we got to go through here and we're going to start by checking colors, making sure everything's going where it's supposed to go. And I mean, everything's wired up where it's supposed to be on the clock, the way it's supposed to be. So we need to look down at the evaporator too and see if there's something funky going on. All right, what I did was I tested power. We had 3-phase. We reset a breaker downstairs, okay? I disconnected the compressor because I didn't want to be tripping anything with the compressor in the circuit. So the compressor has no power going to it. Then what we did
we tested continuity to ground. We had nothing that was shorted to ground, okay? So we disconnected 3 and X because whatever's happening happens when we put it in defrost. And right now, we are not tripped when I disconnected 3 and X. So our next thing that we're gonna do is we're gonna test voltage to see if we're getting proper voltage from in to here. But hey, wait a minute, there's a problem. There's a problem with this clock because look at 202, but our condenser fan motors are running. 1 to N, let's go 4 to N. Why is our condenser fan motors running? Are we on a fan cycle switch? We must be on a fan cycle switch.
Why? Because it's not pumping down.
Wait a minute, wait a minute. Oh yeah, because it's not pumping down, that's why, okay, all right. Yeah, that's what it is. Okay, so condenser fan motors are running because of that. All right, now we have power from 3 to N, which is 208 volts, okay? Oh wait, we lost it. Why did we lose it here? 3 to N, we lost power. We should have power from 3 to N. Oh, what's going on? Something's not right. Look at, we're like, oh, there it goes, okay. Maybe it just wasn't making good connection. So we have power from 3 to N, but something's going on here. So we need to go downstairs and investigate the coil, see if maybe something's miswired in the coil. Right, so I came down here and I think I found what the problem is. So if we look right here, our number 3 wire is going to H3. It should be going up to 3. H3 essentially is neutral or common, not neutral. It's the N wire, the common. So H3 is the other side of the heaters. So basically we're not running through the heaters right there. We should have 3 going to one side, and if you look at H3, it jumps over to H2, then goes through to heater safety, then goes through to N. So we basically have a direct short to line 2. So because basically 3 is going to be line 1 coming down, needs to go through the heaters, then come back to H3, and then that goes over to H2, and then that goes to N. So I think if I take this right here on H3 and put it up to 3, I think our problem will be solved. Now we have 202 volts to the defrost heaters, and I can hear that the defrost heaters are running. Let's go ahead and test one. And we have current. So I'm going to test to make sure all the heaters are working. We just had an error in the electrical, and that's why we test everything before we leave. That would have been a crappy call if we didn't test everything and then we had to come back in the middle of the night, right? So all the defrost heaters are working and we're good to go. It is back on. It is in refrigeration mode, but we're waiting for the temperature controller to call. So it brought the box temp up pretty high when we ran it through defrost and everything. So here in a second, the temp control should call and the fan should go to high speed. They're running in low speed at the moment because this does have a 2-speed operation. There we go. High speed. And it is on and running. All is well. It's all sealed up. Everything's good. Again, it's going to take time to bring this box completely down to temp because it got nice and warm, 40-something degrees in here. So as we're running on the roof, this unit does not have a head pressure control valve. This one just has fan cycling. Therefore, we just clear the almost impossible sight glass to see because the manufacturer did not think things through when they put the sight glass where they did with the giant suction line in the way. It's just so dumb, but whatever. I look forward to the day that we cut that out and put a Sporlan dryer and sight glass and be done with that stupid stuff. But I mean, come on, move the sight glass up 2 inches, 3 inches. That's ridiculous. When the cover's off and it's raining and you're trying not to get everything wet and you're trying to charge a system, all you can see is a suction line. I mean, even if you go way down there, you know, but like that's, you can't, it's hard to get your head down there. That's just dumb. Now you take the top off, you can kind of see it, but whatever, you know. Pressures wise, got 100 saturation, about -1 vapor saturation. That's not too bad. These things are super efficient. Again, we're running a clear sight glass. It's coming down in temp, cold suction line coming back. My saturation's a little bit lower on the low side than I want it to be, but again, we're gonna let it operate, let everything break in, because we're not gonna try adjusting the expansion valve when the box isn't down to temp. So as long as there's no major problems and it's cooling, we're gonna leave it be. We're not flooding back. We'll come back and we'll check on everything, you know, like I said, later. So in a day or two, we'll come back and check evaporator superheat, maybe even adjust it a little bit. So I came back the next day. It's like 3 o'clock in the afternoon and the thing's partially frozen up. They've got frost all over the shelves, all over this stuff. They're clearly leaving the door open. Brand new. They're already leaving the door open. Come on. So I'm putting it through a long defrost right now, just a little bit of frost on the front of the coils that still needs to melt off, and then we're gonna hopefully be able to check superheat. All right, it just kicked in. It's all defrosted, everything good. So I've all probed up upstairs and downstairs. Voltage meter upstairs, testing amps on the compressor, and I'll be able to just watch the unit come down to temp, evaluate its operation, sitting down here in the air conditioning. So kind of nice. Fans just turned on, so now we can just let the unit operate. We'll go sit down and watch the pressures outside. So basically, instead of just sitting down upstairs waiting, I can be here. So I've got a voltage meter telling me we're on a time delay. There's an anti-short cycle time delay at the contactor. So we know when this turns on, but we can see everything else. We're registering about 107 degrees on the roof. It's not quite that hot. I think it's getting some radiant heat off the roof deck right now. All right, we can see now my compressor's running at about 7 amps right now. 201 volts being delivered. See, the outdoor air is already dropping as it starts moving air because it was just getting radiant off the roof basically. So we're gonna let the box run for a little bit. I want to evaluate superheat, but we really got to let it run for a while. Interesting numbers I'm looking at. I have a clamp up on the roof getting suction line temperature. 41 degrees on the roof, and then 14 degrees down at the evaporator, so we're gaining 26.5 degrees of temperature in Fahrenheit, obviously, you know, through the insulation basically, running through the hot attic. So we use 3/4 wall insulation. I'm curious how much of a drop in heat gain we would have if we used 1-inch insulation. Pretty interesting. I'm bored here just watching this thing come down to temp. It's gonna be a while, so my box temp right now is at about 18 degrees. My saturation's really low, so I'm expecting some superheat adjustments here. But I'm gonna give it some more time because I don't wanna go cranking on the valve yet. We currently have 24 degrees of evaporator superheat, which is too high for a freezer. But again, you don't really want to adjust on the superheat until it comes down a little bit more in temperature. I might go do a couple cranks on it, but I just wanna be careful because as it gets down to temp, it can really start acting wonky if you adjust on it too much. All right, I'm watching the superheat kind of range. I did make some adjustments on it. It dropped down to about 4 degrees superheat, then came back up to about 9. We're almost down to temperature. Box temperature is at about 10 degrees, so we're getting there. Still tripping out about how high our TD is. Evaporator TD is 28 degrees. All right, this is about as far as I'm gonna watch it come down to temp. It's ranging between 5 and 8 degrees evaporator superheat. Box temperature is at about 7 degrees. I'm pretty confident we're good. I'm not really too worried about this. So in hindsight, I wish that liquid line would have been straighter, but it's polishing a turd on this roof. There's really nothing going on, you know, like there's no great way to support everything. This wood, like we're gonna have to do something eventually, but you know, this equipment doesn't even last that long. This guy right here, sight glass is clear, everything's good up here, no problems. You can't see the sight glass, that's something that's silly. I pointed it out, like, you gotta barely, nope, can't even see it there. You gotta take the whole top off to see the sight glass, which I think is a bit silly, but it's working about as good as it's gonna be. I'm not a huge fan of, you know, how everything turned out. I don't like the mismatch on the equipment, which I think is leading to that high TD. But I didn't buy this, you know, the customer buys this stuff and has it shipped, and you know, it is what it is, right? So I want to ask you guys something. Towards the beginning of the video, before the crane lift happened,
there was something that happened. Nobody got hurt, but someone could have gotten hurt because of something that was done improperly. And it's a learning lesson, you know, had a discussion about it. I'm curious if you guys caught what it was. Okay, so let me know in the comments if you guys caught what happened. Before the crane started lifting, something happened and someone could have gotten hurt, but they didn't. So I'm curious if you guys know what it was. Okay, it was all cool, nothing bad happened. I'm not going to say what it was because I'm curious if you guys caught it. But I did talk with the other person and just said, hey, you know, there's a better way to do this. That way you potentially don't get hurt. Okay, so I'll leave it at that. Let me know in the comments if you caught it, what you think. And remember, you always want to take care of yourself. You want to think about yourself first, right? Your body is very important to you. You don't want to hurt yourself. Okay, so let's talk about the crane incident. So I was having someone else signal the crane, and then when it came time, I took over the signaling when we were lifting or directing the crane over to lift up the old unit. And I was directing the crane, and I told him to boom up. Okay, I said boom up because what was happening was the ball was too far past the condensing unit. And so instead of hoisting down, I said boom up because as he booms up, it would have brought the ball would have traveled closer to the crane. And I was going to tell him to boom up until the ball centered over the condensing unit. Then I was going to tell him to hoist down, right? Well, when I told him to boom up, he started hoisting up. And it took me a minute to realize what was happening because I wasn't watching the end of the crane. I was watching the ball. And so I saw the ball going up, and then my other guy, Will, that was on the roof, what you could see kind of the confused look on his face because he was telling me to boom up, right? And he's like, wait, what's going on? And then I finally realized what was happening. The crane operator thought I was saying hoist up when I was giving him this signal right here, which is the signal for boom up. Lift up the boom, and the ball would have moved, it would have traveled towards the crane because as he naturally lifts the boom, right, and he's got a load hoisted or even the ball, as he lifts it, the ball is going to move with the boom, right? So anyways, I was a little bit bummed that the crane operator, and I had a discussion with him after, and it totally makes sense, okay? Unfortunately, there's too many people that don't understand proper hand signals, okay? And the crane operator did explain it to me, and he said, look, he goes, a lot of people give me the weirdest signals, and sometimes I don't know what they mean because, you know, he said that a lot of times people don't understand the proper signals. So he's used to dealing with people doing move or these weird hand signals and different things all the time, right? So, you know, and again, but it's still, if you're giving someone proper hand signals, if someone tells the crane like this, boom up, that means boom up. That doesn't mean hoist up, right? It was all good. It was, you know, not a big deal, but it is frustrating. And it is kind of scary if you're giving hand signals to someone. It just goes to show that you really, really need to be paying attention to what you're doing. That one took me a couple seconds. Luckily, nobody got hurt, right? You know, and it is what it is, but I'm noticing this kind of stuff more and more. Okay. It's just one of those things. So let's get on with the job. Overall, the job turned out pretty good. Couple things that I didn't like. Okay. Number one, obviously we had an electrical mishap, but it's okay. It happens. Okay. Had a discussion with the guy that wired up the coil and just said, hey, look, you landed a wire on the wrong spot. He landed it on H3 instead of number 3. I get it, okay? Honestly, why do they have H3 on there? It's kind of silly. They should call that something different, really. I get it. It's heater 3, but come on. Call it something different. That's just a silly thing. You know, whatever. Life happens. You know, we figured it out. It was all good. You guys saw me troubleshooting through the problem. One thing that I will say is you know, I thought maybe I was going to have to turn, and I did. I turned the power back on, but I pulled the compressor out of the circuit because I didn't want, you know, it being subject to shorting something or something, you know, when we were trying to troubleshoot it. So words, to, you know, something to think about when you're doing that kind of stuff. The other thing that I really didn't like how it turned out, and, you know, I get it, is the way the liquid line. Like, I really, you know what I probably need to get is one of those 3/8 line straighteners. They make like a line straightener. It has a bunch of ball bearings in it. And when you travel it back and forth, it actually straightens out the line. I probably need to pick one of those up because that would have really helped in this situation. I could have straightened out that liquid line a little bit better. But, you know,
sometimes is polishing a turd when they don't really have the proper stuff on the roof for you to wire these things up. And, you know, it is what it is, right? Life happens. You can't always be perfect. Other than that, there's a little bit of a mismatch as far as delivered BTUs for the evaporator and the condenser, and I do believe that was partially, or if not completely, responsible for the high TD that we were seeing, the evaporator TD. But other than that, everything else really went okay. I mean, it's just a normal, typical job. Like I said in the very beginning of the video, I really, really wish we could spread this out over a little bit more time and we weren't under such a rush trying to fix or replace, do a complete retrofit, evaporator, condenser, and line set in a short amount of time. You know, I really would have liked to have been able to do that and spread it out over 2 days, but it's not very practical. These customers don't want you to do that. But man, you know, if you've never experienced a refrigerator truck when you're trying to do a retrofit, refrigerator trucks are so much nicer because you just don't feel pressure. You're just like, okay, I'm just doing my thing. Customer's not coming in and out of the box. You know, we're not trying to keep the doors shut, all that good stuff. But, you know, this is just the kind of stuff that I work in, and you have to learn to do this stuff a lot. And, you know, sometimes you get spoiled when the customer has a refrigerator truck, but it's not very often for me. So we did our best within the time frame, got the system operational, and everything turned out pretty good. You know, there's little things here and there, but, you know, again, you can't always be perfect. So I really appreciate y'all. Please leave me some feedback down in the comments. If you haven't already, please consider checking out my website, hvacrvideos.com. Merchandise available on there, all kinds of different hats. We have the dad hats, we have the flat bill hats, we have the standard original hats like this one, beanies, sweaters, t-shirts, all kinds of good stuff on there. So check it out, hvacrvideos.com. If you guys are interested in supporting the channel, a really good way to do so is go to truetechtools.com. If you're interested in purchasing any tools and they have something that you like, if you like their pricing, and I can vouch for their selection, I can vouch for their customer service, and their pricing is pretty darn good too. But if you use my discount code, big picture, one word, that is an affiliate code. You get an 8% discount when you use that code, and then I get a small commission. That's a great way to help support the channel. A couple other ways, but the easiest way to support this channel is literally just watch the videos from, just watch them. Okay, just watch the videos completely. That's the easiest way, okay? And then there's another couple other methods, PayPal, Patreon, YouTube channel memberships. All of those are great ways too. There's links in the show notes of this video. And that's pretty much it. I hope you guys have a nice Independence Day for those of you in the United States. The 4th of July is coming up. I hope you guys get to spend some time with the family, have a great barbecue. That's what I'm looking forward to, having some friends coming over, barbecuing, hanging out, and just hanging out with the family. So I hope you guys get to have a good time too. Thank you so very much for all the feedback, the support, the comments, the interaction you guys have on all my social media platforms. It's very humbling. I really do appreciate you, and we will catch you on the next one.
Okay, we got the drain line in. We need to seal up the holes. Line set is ran, P-trap. Now, we used the rubberized insulation, but we changed to this right here.
You dumb.
All right, so we got the line set ran.